And while we are trying to transport it, there are a number of parameters which we have to look at. The first one is whether the requirement of the application have been met with or not. For example, it wants the data to be moved within 1 microsecond. The network should support a transport of 1 microsecond, the data is. So in this context, we'll try to look from computer networks what are the options available for IoT and how it is being used. So as we try to see the different types of technologies available to us, and if we try to look at the characteristics of those networks, we have features, the range starting from short distance to a long distance, and the long distance is up to 10 to 20 kilometers range, what we are trying to look at. So the distance is a long range communication, and if you try to see the x-axis, we are fixing the range from short to long, and the y-axis is the bandwidth we are trying to look at. So if you try to see the most of the IoT devices, they transport very small data. But as such, the other devices like cameras and videos and all, you require high bandwidth. It's not that small bandwidth is sufficient. So in that case, if you try to see the overall network structure, you have the Bluetooth low energy, BLE we call it as, and we have Wi-Fi. And mostly these are very popular in short distance, like within a house or within a locality or within a lab or within some small building and so on. So the range is only up to few meters, few tens of meters. So you can think of something like 100 feet, 200 feet, it can cover it. And Bluetooth only can cover up to 50 feet or 20 meters and so on. So we have these two at the low range or the short range. And mostly the applications which we try to run on top of it is voice, music, video, multimedia, home IoT, and such type of communication. We don't use it for a long distance communication. And when we are trying to look at the other options which are available, like cellular networks, if you try to see, there is a vast difference between this network and this network. Here it is free of cost. The spectrum is not charged, whereas the spectrum is charged over here. You have to pay whenever you want to use it, like your mobile service. Your mobile services, you pay and use it. It is not free of cost. Whereas your Wi-Fi and Bluetooth, you are using it for free. The spectrum is free. Once you buy a device, you can use it, right? So this is a paid service. The spectrum is paid one, and you get range sufficiently long where you can communicate. For example, if you have a mobile phone, you can communicate in a cell site of 2 kilometers radius, and it is sufficient for communication, something like a mission critical applications. And mostly the cellular network is a outdoor activity. It is not indoor. The base stations are outside, and you can be indoor or outdoor. The user can be either indoor or outdoor, but the base stations and the structure is outdoor only. Whereas Wi-Fi and Bluetooth, we keep it inside the house. We don't keep it outdoor. So this is one of the major difference, that the application is outdoor and this is indoor, and we can communicate to a longer distance in the cellular network because the power used is a high power activity, and mostly we try to use for mission critical application. Mission critical means there is a flood and you want to monitor it, then satellite, the telephone network can be used, or if there is some type of accident or some fire accident and so on, you can easily monitor with your cell phone network. And there is another network which has been specifically been looked at for IoT only, right? And such type of things, if you try to see, we have LoRa networks. And apart from that, there is one competitor for LoRa networks also. We call it as Sigfox. And mostly that network is not used in Asian countries. It is in America, it is very popular. So we have a Sigfox and LoRa networks, and both are using the spectrum which is used over there is free of cost. It is not chargeable, right? So you can assume that this is free of cost, this is free of cost, only this is chargeable. So we divide like the spectrum whenever we look at unpaid and paid. So this is broad classification. Whenever we look at spectrum, we have an unpaid spectrum, we have a paid spectrum. In unpaid spectrum, you cannot communicate for a longer distance, but a paid, you can use it for a longer distance because you are authorized to use it, you are paid for it, so you can use it. And that also they'll charge, some companies try to charge you on usage basis, some try to charge on fixed basis and so on. Like you can get prepaid fixed charge and postpaid, you can use whenever you want to use, you pay for it and use it. So these are the difference between paid and unpaid spectrums. And in the new network called as LoRa network, this is low powered high range network we call it as. And in that case, you can see that the distance covered is much longer than the cellular networks. Right? This is one prime important for us. And mostly if you try to see, the activity is low cost, low power sensors, actuators and tags. And all the devices which we are trying to look in the IoT will come into it. So this is mostly by definition you can take. It is given in this source. So you can see that the RFID tags are very short distance communication. You have to go closer to scan it and get the information. I think you might have experienced it in most of the malls and all. There is a scanner, they bring it to the product and scan it and see. Right? So that is RFID. And there is another one which is very similar to RFID is near field communication, NFC we call it. All your credit cards are NFC only. So you take the credit card near to the device, you get billed. You need not have to do pinning and all these things, right? So there is one more technology called as NFC technology, which is most of the credit cards, most of the mobiles, everybody have that one. So you have to just go near to it and use the application, get connected to the server and transfer of the activity will happen. And this is very popular. Why we say it is very popular is, the other name for this is tag. So if you try to see the cattle like sheep or cows and all these things, they are being tagged so that we can monitor them where they are. That is first instance. Second is the health of the animal can be monitored. We know exactly what is the health of that animal. We can find out exactly, like whether it is, for example, one of the case studies somebody has done it, the cow is pregnant and they can know exactly when it can be delivered, the baby can be delivered and so on. So they completely analyze that one and they can see what is the activity of the cow every time. They need not have to go to the field and wait also, right? And they connect it to the veterinary doctor, so the doctor arrived at time and things are happy-ended over there. So please remember that these tags are not just for clothes and some food stuff and all. It is for most of the, what we call it as like cows, sheep, all these cattle, birds, everything they are putting tags on it so that they can be monitored. Right? And this is another one where we try to use for these, nowadays popularly they are trying to use it for the the school buses also. So that they can be tracked where the bus is and what time they are coming and going and everything. Another important aspect, if you try to see, the US, even the children are being tagged. They know whether the kid is where they are, whether they are going to school and coming back, everything can be monitored. So in India, we don't take it very seriously, the RFID, but most of the Western countries, they use these tags very popular. For everything, they use a tag, right? So this is one important thing where people are trying to use maximum income out of it, and even applications are also there. And apart from that, we have BLE. This is what we call it as low energy. Bluetooth low energy is BLE. And Bluetooth is there, but nowadays no one is using Bluetooth. They want low energy Bluetooth only because they cannot drain their mobile while keeping the Bluetooth on. And if you try to see the modification of the Bluetooth over here, the distance has improved very much. Right? It is going up to 100 meters also. In some cases, you can drive it to 100 meters also. Okay? And the competitor for Bluetooth low energy is Zigbee or Z-Wave. These two are very popular. And if you try to see this Zigbee application, you can almost it is parallel to your Wi-Fi only. The data rates will not be there, but the energy consumed is very small compared to your Wi-Fi applications, right? So the Wi-Fi, I think I need not have to explain over here, but please remember that we are not in Wi-Fi, we have gone to Wi-Fi 6, even 5, right now this is Wi-Fi 5, where you can operate at 5 gigahertz. Now Wi-Fi 6 has came up where it operates at 6 gigahertz. And what is this the 5 and 6 and all is, in Wi-Fi you have only a small bandwidth for your application. It is around 85 megahertz. When we move to 5 gigahertz, you get around 120 megahertz bandwidth, where you can transmit at a higher speed. If you go to Wi-Fi 6, it is around 1200 megabits per second, which means that gigabits you are trying to use. It is competitive more than your fiber also, right? So please remember that we are moving on to Wi-Fi 6, where the data rates are running into gigabit per second. So now if you try to look from the cellular network point of view, this Wi-Fi is giving much better bandwidths and data rates, right? So which means that Wi-Fi 6 can compete with 5G telephone exchange, right? Even 5G we define that it is the bandwidths are very high, the applications are very high and all, but please remember that when we try to look from the Wi-Fi 6, it is almost equivalent to a base station. So if you have one in your building, all of you can get connected to that. So nowadays, what we call them as a Pico base station. The mobile base station only. In the Pico version is a smaller base station, which you can keep it on the base, the top of your building, and all the people in the building get connected, right? So this is about the middle range, and this is Wi-Fi hollow, which is giving you up to 100 meters, but now people are trying to move up to 200 kilometers also. So apart from that, I have told you that we have licensed and unlicensed bandwidths. So the black one is licensed one, and this is the costliest one among all these things. So in the chart you can see the light blue is less cost and the black one is the highest cost. So the cellular network, if you are trying to operate, you have to pay heavily the money into it. So now here if you try to see mostly the cellular networks, we are trying to put it as 3G, 4G and 5G. And that the reason is still the 4G networks are there in some of parts of the country, and 3G is compatible. Still it has not been isolated. The old stations have not been removed. They are there. And because the problem over here is the mobile station, if you try to see the base station, installing is costly, removing is also costly. It is not free of cost, right? Removing is more costly than installing it. So people try to leave the structure and go, right? Like you might have seen, there is an aeroplane in our campus. If they leave it in the airport, they have to pay per day some few thousands of rupees. So instead of that, they remove and put it over here so that there is no charge for it, right? So similarly, we have something like that in telephone networks also. The structure itself, removing is very costlier than installing it. So people try to use the same structure, put the new antennas and continue with the same structures, right? So again, if you try to see here, the licensed and unlicensed, this is a module well inserted into the 5G networks. It is not a separate network it is, right? So if you, the architecture of the mobile networks, if you try to see, earlier we used to see that whenever they put a base station, they construct a room and put the equipment and AC and everything. That was in 2G, right? Which means that the network, all the complete architecture is there on the structure, and they need cooling for that because it gets heated up. And as the phases of the network passes on, we separated the module into two blocks. One is control unit, one is user end equipment, right? Data unit we call it as, and control unit we call it as. So I think you might have experienced something like in the demonetization time. So we have to wait for 1 month for the ATMs to get upgraded, right? So do you know the reason for that? The ATM machine, what were there, has been loaded with Windows 95 version, I think. and then they are independent. So the person who is trying to upgrade it has to go to all ATM machines and then upgrade it to the new currency notes and all. And that took around 30 to 45 days. And people got angry and all, I separate story about it. But coming to the architecture, because we are engineers, we want more into the why it has to be done, why can't we do it better? So what we try to do is the panel where we have that control board, which is supposed to take these inputs and do that one, we have separated them from the machine. And we collected all the cards and put it centrally in one place, and with one stroke we are trying to upgrade it. Right? So we need not have to visit all the ATMs. Sitting in the control room, I can change the parameters of each and every machine. So we have separated the data plane and the control plane. And all the control planes I kept it centralized so that I can sit here and upgrade all the machines. So similarly in the network also we have similar type of architecture where control planes have been pulled out from the base stations, and only the data planes are there in the tower, and now they are software defined data planes. I can define the frequency, I can define the user, I can define the radius also, power, everything I can define it sitting here. I need not have to go to the base station at all because they are software defined radios. So I have the controller with me. With one stroke I can upgrade all the base stations. So for example, I have one area where there is for example, municipal office is there and the residential area is there. So you'll see that up to 5 o'clock there will be busy activity going on, and after that it is closed up to morning 8 o'clock. Nobody will be there. But putting an installation over there and looking after it is very costly for me, and I am not using the spectrum also. So what I do now, I can shift the spectrum to somebody else because it is in my hand, the control plane is in my hand. I shift everything to a user area where users are there, and I can give them the access and the bandwidth also. So that is the beauty of now 4G and 5G. I can define my radio, I can define the power, I can define the radius, I can define my users also. So that's how you can see that the 5G and 4G networks, we can divide it in whatever way we want it. Right? So that is what we are trying to look from here. So the LoRa and Sigfox are in the unlicensed band, and we have narrow band IoT and LTE-M. LTE for machines. So now, as an IoT designer, if you are trying to design an IoT system, we have to ask these questions, and then we have to pick up a right communication network for our application. So the first one is range. So I have an agriculture field. I want to put the IoT device over there. I should know what should be my communication rate. Right? So last time we have a project with the agriculture office, one of the agriculture research station. They want to monitor they have experimental tanks and they want to monitor the tanks. So we have been given a job to develop a monitoring station to check on the parameters of the tank. So we are still doing that one, we have not completed. So what happens is they have rice plant only. They kept the same rice plants in different tanks, and they change the parameters like potassium, can they increase or decrease, nitrogen, they can increase or decrease. So they are studying the effects of the plant. So they don't want to go 10 kilometers away the fields and monitor all those things. They want to sit in their place and monitor that. So we are using some LoRa network structure and trying to do that, but that is the key important. The range plays an important role. If I use Wi-Fi and Bluetooth, it is not possible for me because I cannot put too many Wi-Fis on the way and go there. So the best architecture should be LoRa because the range is in the kilometers range, right? So the range will tell you what type of network you are supposed to pick it up. Then the second one is data rate. And in most of the cases, if you try to see the IoTs, they don't demand high data rates. Only in the case of video or some type of multimedia structures you need it. Otherwise, the rest of the things, if you try to see, they are very small. They only measure temperature or pressure or some atmospheric parameters. So in those cases, the data will be in bytes only or kilobytes. It will not be in megabytes. So you have to be very careful in taking up the data rate. And the second thing is how often you want to send the data. You want continuous data or by interval or event driven. So you have various methodologies to collect the data. So based on that, you have to pick up your network again. So next, the power. Since I cannot put the power supplies in the agriculture field, I have to run them by using battery only. So the battery will tell me how much power I can transmit it. Right? If I transmit it for longer distance, the battery dies off very fast. So this is another important thing which you have to keep it in mind. And since in agriculture field, the advantage over there is I can put a solar panel and I can power it on also. So that is advantage over there. But disadvantage is also there, like I have to build a structure and I have to see that the wind and all will not play bad with that and so on. But physically, if I know a good structure, I can keep a solar energy to save that one. The frequency is again an important task, because what happens is in India, if you try to see, mostly we have unlicensed spectrum only 2.4 gigahertz and 5 gigahertz. And around 2.4 we have only 80 megahertz, and around 5 gigahertz we have only 120 megahertz bandwidth. So whether that is sufficient or not, you have to decide it, because I want an application where I have gigabits of data, and if I put something like 2.4 with 85 megahertz, then the time taken to transmit will be very large, right? So you have to see that parameter also, the frequency at which you are trying to collect and how you are trying to transport it. Then finally, the security. This is again a mission critical application where the problem is with not with the sensors, but with the, you can call it as actors. So they try to pose as if they are real sensors, but they have been hacked and they send wrong data to you, right? So those things have to be removed while you are trying to do the experiment. So what we try to do is we put the sensors in a locked mode and we try to open it up and close it whenever it is required. So this will tell you like all the standards which are available and which can be used for your application, and all the names which are there existing people are trying to use is available over here. So if you try to see from the beginning cellular IoT and non-cellular IoT, you can divide them as two categories. One is licensed, one is non-licensed. And in the license, you can see that you have and licensed LPWA, and in the non-licensed, you have wide area PAN, wide area NAN, and LAN, wired, unlicensed, and satellite communication. And this is now increasing drastically high, lot of research and lot of activities going on satellite, because nowadays what we are trying to do is we are trying to connect the unconnected one. People have connected something, so we are not touching that. There are areas where people have not connected and there is no network facility to connect it. Like for example, I have a dense forest. I want to know what is going on inside it. So nobody will put an antenna or something in that. So I want to monitor it. So the only option available is satellite communication. Or if I want to monitor some snowfall or the melting of Atlantic over there, I will not put some antennas and all. I'll only have to monitor using satellite. And that is possible now because of the Musk. He has a low orbit satellites going on, right? Because the low orbit satellites are there, I can watch it from very close, right? So here, when we try to look at the provisioning, we have 2G, 3G, 4G, 5G, and within 6 to 8 months, the 6G will join here, right? Almost the installations have started, and 5G is almost like dead end. And then we get it to the licensed LPW. We have LTE, long-term evolution for machines, M is for machines. And we have NB-IoT, narrowband IoT. So these are again a very popular one for IoT purposes. These are for mobile communication, but these two are specifically only for IoT applications. And that is for massive IoT purposes, not for small IoTs. And in WPAN, you have Bluetooth, Zigbee, Z-Wave. And WNAN, you have Wi-Fi Sun and others, and LAN is Wi-Fi and equivalents, and wired you have Ethernet, RS-485 and USARTs, and unlicensed LPWA you have LoRa, Sigfox. These two are very competitive to the 5G networks, and satellite is VSAT and the direct satellite phones or satellite SIMs. You are getting it nowadays. You can use it in your mobile and you can get connected to satellite also. And this slide is only to tell you that if we try to compare the various technologies available to us with respect to the range, data rate, frequency, power, and the type of standardization, modulations and all we try to use, multiplexing and all, what happens when. So out of it, I'll try to look into two parameters. One is LoRaWAN and Sigfox and NB-IoT, because these are popularly used for massive IoT communication, right? Massive machine type communication means it is massive IoT communication. Because why we say massive? Because yesterday I think you might have hearing the professor, we have around millions and billions of devices on the earth. Like in 2008, if you try to see, the number of machines, the addresses what is available for machines have crossed the number of people on the earth, right, in 2008. So now we are in 20. So it is estimated that right now each person has 8 addresses with him. It can be a mobile, it can be a laptop, it can be a TV, or it can be a refrigerator, or it can be a fridge, or everything. So each person is assumed to have 8 licenses. And if you're in your house, you are 4 people, 32 licenses are there in your house. Not licenses, addresses, IP addresses, right? So you can see the density of IP addresses required for connecting the devices. Then in that respect, if you try to see, these 3 are very competitive because the rest of things will not support so many devices, right? Bluetooth can only connect 7 or 87 devices or 8 devices, not more than that, right? Wi-Fi 10 to 20 users it can accommodate. It cannot accommodate more than that. So these things we are not that much popular, or we are not looking into it. But these 3, if you are into a massive machine type communication technology, you have to look at these 3 very closely. And if you try to see the kilometer ranges, this is giving you 20, this is giving you 10, and this is giving you almost like 10, right? So the distance what it is trying to cover is 10 kilometers radius, I can cover it. Like all the smart cities, if you try to see, they are connected using one of these technologies. Because, for example, you take the dustbin network. There can be 10,000 dustbins in the city, so all can be connected. Or you take the street lamps. There can be 20,000 street lamps in the city, everything can be connected. So there can be taps, everything can be connected. There are electrical meters, everything can be connected, right? So please remember that when you are trying to see the type of connectivity and the range, the 20 kilometer and 10 kilometer range are very good to cover a complete city, right? It is a radius, it is not diameter, right? So 10 kilometer circle, if you try to draw, the complete Warangal will come into one picture, okay? So when you are trying to look at that type of smart cities and all, this is the best technology you have to use. One is LoRa, second one is narrowband IoT, and the Sigfox. But Sigfox uses a different frequency because it is almost categorized as unlicensed. But in India, we don't have. Europe, it is there. And North America is there. And some parts of Asia, it is there. And we don't have this frequency open up in India for unlicensed. But LoRa has been opened up in India. We can get this one, licensed, unlicensed one, we can use it. And one is we have 433 and 868 also we can use it. But this one, 868 it has told, but the 868 is still under testing purpose. We have not gone connected yet. 433 it is working, right? And this doesn't have the 433 in devices in India to connect it and test it. Okay, the market has not opened up for Sigfox in India. Okay, this is prime important. You have to remember these two are unlicensed. You can use without paying it. You buy the device and start using it. And I think you are aware of ISM band, industrial, scientific, and medical band we call it as, and that is free for usage without paying any license fee. Okay, NB-IoT is you have to pay license fee, but the license fee what you are trying to pay is generally assume that the service provider will pay and you have to use free of cost. It is not that like added advantage. If you take mobile, you get one more set free. Like that, you get a band over there, right? And if you try to see the power consumption, the current is very low in these three cases, right? So it is in the order of milliamperes, and all are less than 50 milliamperes only. Okay, so the power consumption is also very low, and hence you can connect more devices onto the network and use it efficiently, right? So please remember that these parameters, these three, if you try to see with the other parameters, they are not so much impressive. And the technology or the access mechanism what are being used for these three networks, if you try to see, the LoRa is the best choice. Like we call it a pure aloha. What does it mean? Like I have a data, I transmit, right? I don't wait for the network access, or I don't wait for the collisions and all these things, right? Assuming that the bandwidth is sufficiently large and my data is small, it goes through. Nobody will object it, right? And if the user density is trying to increase more and more, then there might be collisions which happens and your data might not go through, right? Since if you try to look from the data point of view, this transmits only at maximum data rate is only 100, 600 BPS, and this is 30K. This is one advantage why people are moving towards LoRa rather than Sigfox. The data is very small compared to your Sigfox. It is in kilobytes and it is still in bits per second only. But this is sufficient for the IoT applications. Like weather monitoring station is there. You don't want to continuously send data from the monitoring station. You can take periodically, every 10 minutes you can monitor it and see. Similarly, you can monitor the rain, so it will not change drastically up and down. So it slowly changes. So you can monitor them happily with Sigfox, but still the data rates are very small compared to your LoRa. And if you try to look from the NB-IoT, this one is still lower than this, but this is free of cost. LoRa is free of cost, so you can use it for your application. And the advantage with LoRa is pure aloha. You need not have to wait for transmission. As and when you have data, you can transmit it. In other cases, if you try to see, they are using FDM and OFDM and all, where you have to use a specific carrier and then try to transmit it. And if the carriers are full, you have to wait for the carrier to be free, and then you have to transmit it, right? So this is one application where you can see that the LoRa has the fastest way of transmitting it. And if you try to see the encryption standards, they are almost same. They are using AES 128 encryption schemes only. They are not using different schemes. So the Wi-Fi, if you try to take it, you have 2.4 and 5 gigahertz, and this is the old version. The new version has changed to 6. And the range is approximately to 50 meters. The data range is only small, megabits per second, and the maximum you can get it is 600 Mbps. And if you go to AC standards, it can go up to 1 gigabit standard. And all the smartphones are compatible with it, affordable, and well protected and controlled. All of you know that we have WAP2 sitting on that, and you can use that comfortably. And it uses high power. You need the power supply always on. You cannot run it on battery also. If you run it on battery, it can only stay for 5 minutes or 10 minutes. It cannot stay more than that. And this is a very important thing in stability and inconsistency. It goes and comes and it goes and comes and all. This problem is there. Otherwise, it is good. You have a well protected control. The distance is good. Data rate is good. So now if you try to see the W56, this is what bandwidth is. You can see that the Wi-Fi 6, you have 120 megahertz bandwidth available to you, which means that 1 gigabit, 1.2 gigabit data rate, you can transmit it, which means that if you have a movie, you can download it within less than a minute, right? The movie will be around almost 1 gigabit length, right? Or less than 1 gigabit. So you can get it by 0.8 of a minute, you can get down the movie directly, a normal movie if you try to take it. And if it is more than 1 gigabit, 1 second it takes to download the complete movie. So you can get as if you are seeing the movie and it will not stop in between and all. The movie will run with a faster rate. And 5 gigahertz, you get around 580 megahertz, and this is also good enough, but still, once you have this feature, people will not look at the lower ends, right? Once you have a sedan car, nobody will look at a small cars and all. So this is 83 megahertz, the 2.4 gigahertz bandwidth, and this is what we call it as Wi-Fi, and this is Wi-Fi 5, and this is Wi-Fi 6. And this is from the Qualcomm paper, where they show that the 6E and 5G, the 6E, Wi-Fi 6E and 5G are almost equivalent only. They are not separate, because the bandwidths and all they are trying to support is almost similar to each other. So 2.4 is 83.5 megahertz. 5G you have 100 megahertz outdoor plus 100 indoor, and 255 in outdoor and 125 indoor. So this is what we anticipate that the total is 580. You can add it up, and you can see that most of the activities are outdoor and indoor also they are trying to play. Like if you have here Wi-Fi outdoor also, you can capture it and use it, which means that the distance have increased. And here it is still, you can see that you get 500 megahertz indoor and 500 megahertz outdoor also, right? So you have lower latency because the data rates are very high, the latencies have reduced, and you can have more number of super wide channels. The channels what we are trying to give to each user has been enlarged because the bandwidths have been more, so the channels also. So if you divide that 1200 bandwidth among 7 super channels, you get around how much it will be? 7 means it is 1.5, right? 1.5 means 150 megahertz, like what you have here, you will get like that 7 super users you can use it, right? 7 can be subdivided again and subdivided again for low band users also. Greater capacity, improved performance, because the bandwidths have improved, the performance definitely will try to improve. So this is what the applications which are being trying to use on Wi-Fi 6, and these have been tested also in some of the stadiums and all, where the population is more than 10,000 audience who are sitting in the auditorium and all, stadium and all. They checked it whether the speeds are being met with or not, and there are 2 universities in US which have tested these communications, and they found that users have rated very high, right? And when you try to look at unified communication, I think this unified communication is nothing like teleconferencing. Suppose there are 10 people sitting in 10 organs, they are trying to meet, they can, as if they are opposite to each other, they can have a live discussion. They don't have any what we call blank and again come back, again blank, still picture and continuous. They will not feel that one. That's what we call it as unified communication. And this has been increasingly demanded because a lot of people are working from home, right? When they work from home, the bandwidths are not that good to get connected, and they always report that there is a lag and lead in the picture transmission and so on. So to nullify that, this Wi-Fi 6 will give you a live communication among the users. Augmented reality, virtual reality is again, I think this is very popular for game players. They almost use virtual realities in simulating a thing and see that bike race and all these things will be happening. Cloud computing is another example, telepresence also. The telepresence is something like you can take as a medical application. from remote, the doctor can be accessed, and he can monitor the operation, what is going on there, and he can tell that persons who are performing the operation, you do like this, you do like that, as if he is standing next to them, right? So this is what we call it as telepresence, right? So, and this is a very important thing. Why? Because when in a village or somewhere the operation is going on and the doctor is in the city, if the link is bad, by the time he starts cutting and doing, the doctor link is gone, again it comes back after 5 minutes, the patient will be dead over there. So for the compensating that, what we try to do is, we have been asked to move most of these centers to Wi-Fi 6 so that they get the fiber background and it has a continuous link. And they are trying to use now in Wi-Fi 6 or WPA3, wireless access protocol, we call it as. So you have the protection access, we call it a Wi-Fi protection access. So it is 3, we are trying to use it. So here we are trying to use the number of bits have been improved to 256, not 128, and the number of rounds which we try to do has also been improved. So that breaking it is not that easy, because even the for generating a key, we have to generate some random numbers, and those numbers are also picked up by some other algorithm. It is not the same algorithm which will pick up and all. So there are a mixture of 3 algorithms which are there in this Wi-Fi 3. Then interoperability, I think sir has told you in the morning. So the data has to be exchanged without any human interference. They have to talk to each other. The devices have to talk to each other. Like for example, there is a fan and there is a AC. So once the AC is going below the temperature, somehow that has to be switched off and the fan has to be started. So they two have to talk to each other and they have to do the action along. There should not be any human intervention between those two. Or if the AC is less and a person who is sitting inside is sweating, automatically the fan has to be switched on and then it has to take care of. So this is what we call it as minimal human intervention. The human being will not interfere in those operations. They have to talk to each other and they have to do the operation. And for that, you need a good bandwidth, because when the fan asks the AC to switch off, the link should be available for that to communicate. So that availability itself is what we call it as interoperability. The another important feature, if you try to see, nowadays we have the Wi-Fi or the cellular networks are trying to use Wi-Fi support for data transfers, right? So in 2G, if you try to see, this type of operations are only limited to 20%. And most of the mobile data are moved on the mobile network only. Like when you make a call or you use WhatsApp, whatever it is, you use mobile data network. So if you try to see carefully nowadays, you have LTE over voice or Wi-Fi over voice and all, which means that you are trying to bring your Wi-Fi network into your data mobility. And that has been increased drastically high. 70% of the 5G networks are driven by your Wi-Fi only. So the spectrum, what they are buying it, they are keeping it aside, and which is free, they are trying to move your data on it. So that this spectrum can be given to more number of users and they can increase the user base in the network. And that's how it has to work, because the money what is spent on the base station is not few 10 rupees or crores or something. It is 1 lakh above crores which are being kept in the base station, right? And they have to earn that money within 2 to 3 years, because the 6G is waiting at the door. Right? 5G have not entered in BSNL. If you try to see the BSNL network, they are entering into 4G. 5G is being removed out from the networks, and the 6G is waiting to come into it. So the span is not sufficient for the mobile users to, the service providers to earn back their revenue. Okay? So in that case, what we try to do is we have to accommodate more and more users so that we get some revenue out of it. And for doing that, they have to have the spectrum. And the license spectrum is cramped over there. So the other option is move on to the mobile data network, the Wi-Fi network, push all the users onto the Wi-Fi network, and then use the spectrum more efficiently. right? That's what we call it as offloading mobile data network onto the Wi-Fi network. We are pushing all our requirements onto the Wi-Fi network, and then we are doing our job comfortably with the spectrum what is available on the network. So this is again the 5G network architecture, and this is the ITU definition only, it is not mine. So you can see that the network, the base station, can cater to three needs. One is EMBB, enhanced mobile broadband, and massive machine type communication, and ultra reliable and low latency communication. So the network what we have at the base station is divided into three parts. One part is related to the mobile broadband, where the users will get gigabits data rates, right? So the mobile users are very happy with it because they are getting more and more data rates. And at the same time, the massive machine type communication, people are getting around 10 to the power of 6, that means 1 million devices you can connect in 1 square meter. So that type of connectivity it is trying to provide you. 1 million devices you can connect in a square, 1 kilometer square. Okay, that is what we refer it as massive machine type communication. And there is ultra reliable and low latency communication, where the latencies have been dropped to millisecond. And if you go to 6G, it is in the order of microseconds we are trying to drop it, which means that if something happened here, at the other end, you can see that something has happened here, right? So this is what latency is what we are trying to speak. And this is primarily important for all your industrial IoTs, right? You cannot wait for the lathe machine. If it starts cutting, if you take 1 minute to stop it, then the part will get damaged. Precisely it has to stop at one point. So exactly it has to communicate and machine should stop. So the latency over there, you don't have even milliseconds over there, it has to be still less. Or robotic operations, you need a precise one over there. Or movement of the, if you see the manufacturing units, the Maruti and all, we call it as a horizontal layouts. The first part will be fixed and it moves ahead, second part will be fixed, move ahead, third part will be fixed, and so on. The robots will be trying to fix it up. So if there is a delay over there, then the second phase robots will do their operation without the parts only, right? So the movement has to be very precise, and they have to be execute the jobs at the defined time only. We call as time-sensitive networks. So they have to exactly follow the timings in the network to get the result out. So in that case, you cannot play with the latencies over there. I'll take half a minute break and then come back. You don't have that freedom with you, right? So that's what we are trying to look at over here. The milliseconds have been dropped to microseconds, and these densities have been dropped to more than a million, 10, 100 millions, and so on. And the gigabits have been moved to 10 gigabits, 20 gigahertz, and so on, right? In 6G, we'll get those things. So, and these, as I told you, it is a programmable one. We can program the resource such a way that these three are met with. So please remember that nowadays we have software-defined architectures where you can define mobile data rates, you can define massive machine type communication, or you can define ultraviolet. So the user, when he wants to get into the network, he has to tell which type of service he wants it. Pick up that service and do your application, right? So if you try to see the enhanced mobile communication, you have HD, we are trying to use ultra high definition, we are trying to use the videos in your TVs. It is not, nobody, people are interested in 4K, 8K and all. They want HD. HD is also gone ultra high definition. So this is trying to move on. So you demand more and more bandwidth over here, which 10 gigabits are available for you to do that. And AR, VR is there, cloud gaming, enhanced mobile media. On the mobile, you can see your movies and all with the same clarity what you get it on your TVs. And you have broadband TVs, in-venue wireless broadband, in-car operations. All these things can be met within your 5G with 10 gigabits bandwidths. And similarly, low latency, if you try to see, you have industrial automation, remote manufacturing, surgeries and all, and self-driving cars, ultra-reliable application, whatever you define it, it comes into. Then machine-type communications, massive machine, buildings, all the smart cities, smart homes, smart transport, smart hospitals, everything will come over here. Energy utilities is not only electrical, water, everything you can monitor it. Smart agriculture, logistics, smart cities, whatever it is, in the indoor activities, all will come up over it, right? And the latencies are only 1 millisecond. The connectivity type is 1 million devices you can connect in a square meter, and 10 gigabits bandwidth in the case of enhanced broadband. So this is what we have looked at it, and we try to go through these two. Rest of things, I think we can get it from literature and all, because these are morely towards the IoT. Rest of things are home connectivities, we can call it as. So coming to the license, we have three options: LTE machine, EC GSM, and narrowband IoT. So this is, we'll try to go through these three, and if time permits, we'll take up the next one. So LTE stands for long-term evolution for machines, and it is a low-power wide area network, supports IoT device through low device complexity, and you can coexist along with 2G, 3G, 5G mobile networks. Battery life is 10 years. That is prime important, because if you want to extend your battery life, this will give you, LTE-M will provide you an efficiency of 10 years, which means that doesn't mean that you put a empty battery over there and say that it is not giving me 10 years, right? The device, if you put a good battery of whatever we have seen yesterday, if you keep that, and if you use LTE-M, the battery life can be extended to 10 years. So you have both indoor and outdoor coverages, good coverages, and support massive number, like I told you, 10 to the power 6, low delay sensitivity, ultra low device cost, and the power consumption is low, and network architecture is minimal, because you are trying to get to the base station only. It is not that you are going to separate networks and all. And the security features are similar to your mobile network only, because you are getting the things from the mobile network. All the features of mobile network are still valid over there. You are not having a separate one, okay? So all these features what are there in your mobile network are extended to LTE-M. We are not putting separate things into that, okay? Only thing is we are trying to see the low energy communication, and here the important thing is how we know what is the energy used. Like we are saying low energy and all, but first of all, who tells that network that my house is so much far away and all, right? So we have a dynamic algorithms where it tries to learn on itself. We call it a self-learning algorithm. So it sends a test bit and it gets back the response. Based on the signal strength of the response bit, it tries to adjust the power. So it goes on adjusting until it gets the optimal value and uses that value for transporting the data. So why we have to do that? Because the base station, the user might be near or it can be far away. So both cannot be given the same power. So one user has to be given minimum power, the other one, the power has to increase. So we need some type of learning algorithm, how far it is, and adjust our power until sufficiently needed. Needed means your receiver have a sensitivity, the received signal should be more than that sensitivity value. So we go on by stepwise and do it. So they are good algorithms. Even if you go stepwise, increment delta, 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 it may take very long to reach there. So there is a dictionary method also. You divide half and look whether this side or that side. Again divide half. That's what we do in dictionary. If we want the alphabet, we open the dictionary and see which type we have alphabet. Again you open that one and see where it is, and so on. So that is faster way of reaching to that. So there are, like that we have a lot of algorithms over there, but still some mechanism should be there so that you use the power as low as possible. You have to learn by iterative methods and get to reach there. So the next one is ECGSM, extended coverage GSM we call it as. and the standard name is ECGSM IoT. And this is what we are trying to look at very carefully, like because the old structures what are there, the 2G structures, we want to use it for IoT. That's the basic idea of ECGSM. So the GSM networks are 2G networks. So the base structures what are remaining in the existing architectures are the places. We want to use them for IoT purposes. So because we are not investing anything more, the structure is there. Only thing is we have to change the panels. So that if you do it, then it can be used for low power applications. So this is one area people are trying to do, but this has not fetched anything. People have stopped research on that. And they are moved towards the narrowband IoT, right? So the narrowband IoT, if you try to see, this is low power wide area network only. And you can see the services what it tries to provide is like your Windows plug and play. So when you have a device, automatically it gets connected to that. We call it a plug and play architectures. So when you put a device, automatically the Windows will detect it. So such type of operations are there, and even the power consumption of the users have been increased. Okay, so system capacity, spectral efficiency, deep coverages are the another prime important, and the life is also 10 years, right? So when a device is connected to NB-IoT, you know that very low power is being used, and hence your battery life will try to extend, right? So this is, if you try to compare these two, because these two are the prime contenders over here, LTEM, which is again I am 10 years, and the NB-IoT also says I am 10 years. We have to compare among them, these two, and see which one is good for our application. Because this one is not saying that I'll give you 10 years life and all, right? So we have two competitors, NB-IoT and LTEM, and we want to see which one is good for what type of applications. So if you try to see, we have LTE category 0, LTE category M1, M2, and non-BL also. So if you try to carefully look at these things, this is category machine 1, machine type communication 2, and so on. And we have narrowband 1 and narrowband 2 and all in NB-IoT. The data rates, if you try to see, their data rates are very high in the LTEM compared to NB-IoT. That is one important thing. So I want to monitor some area. I kept a camera. I have to go for this type of communication rather than this. If I have a weather station which I am trying to monitor, this is sufficient. I need not have to go to this, right? So this is the data rates which tells you which type of application. And similarly, if you try to see the frequency, here I have not written. Let me go to next slide. So the mobility, this is more important. So if I kept the IoT device on a vehicle and I am going around, then which type of network I have to pick it up, right? If I see that mobility is supported by LTEM, not by NB-IoT. The handoff procedure is not there in NB-IoT. Again, the call has to be dropped, and again it has to be connected. So when I am going continuously, NB-IoT cannot be used. If it is stationary, NB-IoT can be used. If it is mobile, then I have to go for LTEM because it has network structure to carry on, right? So you have this handover process in the LTEM, and you don't have this support in NB-IoT, okay? So just keep in mind that whenever there is a mobility, we have to go for LTEM. If the mobility is not there, you can stop at NB-IoT. And if you see the coverages, mostly if you try to see, the Asian country, the blue one, if you try to see, we use NB-IoT rather than LTEM, right? Which means that the applications what we are trying to develop right now are stationary applications only, either agriculture field or in the house or somewhere else outside dustbins and all. They are not moving around. The dustbin will not be running up and down. It will be stationary over there. So such type of thing, electrical pole, these are all like stationary objects, and we heavily use the NB-IoT, which means that we are not using high-speed mobile or high-speed car. You are not trying to use that mobile and sensing and all these things. Whereas if you try to see the North America and South America and the Australia, you can see that they are predominantly using both the things. Right? And if you see only LTE-M, there is a small region called Mexico and some Caribbean, I think it is. There we try to use that. Okay? And South America, South Africa also, they try to use NB-IoT. Okay? And most of the places they have not started yet in the Africa and all, but the rest of the world, majority of the people are trying to use these IoT devices. Right? So let me summarize this, like LTE-M and NB-IoT, both are good for IoT applications, and mobility, LTE-M is better choice, and if you have coverage, GSM is best one because the GSM towers are always there, they can cover the complete city, already there, we need not have to deploy new things and all for coverages. Power consumption, both are good, lower power only, both are saying 10 years, right? And transmission rate, LTE-M is better than the NB-IoT because you have megabits of data rate and this is only kilobits. So this is a small summarization of what we have seen. And nowadays people are popularly use smart meters, electricity meters and all. You have NB-IoT, even the air quality control applications, NB-IoT, GPS trackers are LTE-M because they will be moving up and down. And mobile POS terminals are also LTE-M. So this is only a view of what is existing and how we have to select them for your application, right? And I am not going to the basic things like NFC, RFID, Wi-Fi, Bluetooth and all because we are being using it for long term. It is nothing new over there. Only thing is Wi-Fi 6 is competitor for 5G. So I'll stop over here, it is 3:30. So 4 o'clock, who are the people who are trying to, let me switch off this one, otherwise it goes into recording.